everyone. Today we are going to test another project, that is a public project. Um, well, that is the Universal Robots. They are Robotics Arm from, well, this is the brand, and we are going to work on a local workspace. I wanted that you see the assets of this project. You can see that we have a robot with its gripper. Then we are going to use a maze as an environment, but we can uh, choose many others. We import them, and we have two components. The first is a movie setup for the configuration of the UR3, and the second is an script for motion. Well, and yes, here we have two workspaces that are available as assets. Well, I have um, already available my workspace, but if you don't have one, please create one. Then press from workspace asset and choose the Universal Robot second version. Well, that is this one. So I will open the workspace, and well, let's check the documentation. What we are going to do is on the first terminal we are going to install Movit. Then we are going to compile the workspace. And then in order to start the simulation, we are going to export um, and to this environmental variable. And then we are going to start the world. On the second terminal, we are going to launch the robot. And well, then on the third terminal, we are going to start the movie configuration. And finally, we are going to test the script, test the robot by using a script. Well, we need to wait for a time. As you could see, Asimovo is a robot DevOps platform for developing and testing robots. You could see that we have here assets, and this is a very useful approach because we can have many robots and environments, and well, then we start projects very quickly by launching things, and then we can focus on writing algorithms or specific solutions. I forgot something here. I forgot something mentioning something. Well, we are working with Asimov Olokan. If you don't know what it is, please follow the attached video and documentation in order to work with Asimov Olokan. You can see here that My Asimovo client is running, so I just need to wait. Usually it takes quite long because we have a Docker container, but now it's not on the cloud. It is located in our computer, and well, if it is heavy, well, it takes some time. Well, let me start many terminals because this project uh, launches many things. Well, um, here it is the documentation. Well, first start by installing packages related to move it. Well, we need to wait for a while in order to compile the project. If if you want this project, you can run um, just using Asimovo Cloud. It is okay, but I am showing how to start the whole project by using Asimov Olokan. Okay, now let's compile everything. Okay, all the packages were compiled correctly. Sorry, the instructions are here. We need to export this environment variable because we need to be able to see the meshes of the gripper. And now we are going to launch the robot arm. But let's change this because if we were working on the cloud, we need to set this argument to true because things are going to appear inside the platform. But since I am using Asimovo local, well, I am not working on cloud. I mean this container, this of our workspace are locally. The platform at this moment is only be used for having the terminals. So you can see that I have my work already started. Okay, okay. Now, oh, sorry. Well, first of all, let's source the installation. Yes, for every terminal. And let's launch the robot. Let's spawn the robot, sorry. Oh, it fails. It is strange. Well, let's launch again. First, the war, and now the robot. And let's check what can be, if something is wrong or it was just a failure of the first launch. No, there is another problem. Yes, this is very strange. Let's try one more time, but it is not the expected behavior. That's true. This project need a review. No, things fail. So sorry for that. I will take a look of what is happening. Yes, because what is expected here is that the controllers get activated and then the robot appears. Okay, yes, that was strange because uh, okay, I I think I forgot to source the project, but even if it was compiled previously, because you can see here that now the robot is in the war and everything is running, right? Okay, well, let's continue. The most important thing here is that you check that these controllers are activated. The gripper, the joint trajectory controller, and finally the joint state broadcaster. Because if these controllers are not activated, um, this launch basically failed because you will not be able to command the robot arm. Well, now let's move. Well, here he said that if you want to start to launch another kind or type of universal robot, well, you can specify this argument. Well, then let's go to let's start the move group. Asimov group is started correctly. Here in the documentation says that please don't worry about the error message that appears in the screen. They are well, they are a bug of the mimic joint. So don't worry about that. And let's move to the next script, which will move the robot. Oh, okay. Okay, this is started, and here please don't worry about this because it's of the mimic tag. You can see that the robot in this test is closing the gripper. It is running slow. I think it is because we should set the environment variable for the GPU. So for the next time, it is really important to take that into account. Well, you can see that well the gripper is almost closed, and then this test script moves the robot arm to an arbitrary position. Yes, definitely. It is very important to set the GPU, configure our GPU if we have one. So please, in a moment, I will show you the commands in order to enable your GPU because I forgot to add those commands for this project. Well, the robot arm first moved to a arbitrary position, and then the robot is moving back to home. Okay, okay, now the robot is here, and you can see that now the gripper will start opening, if I am correct. Yes. Well, uh, all the scripts are available on the asset, in this case, for the manipulation, and you can check them. And if you consider, you can modify them, or yes, you can modify them for your specific task. I think The gripper is, yeah, it is almost open, completely open. You can see that it is still moving. Sorry. It has um, a delay because it is running on my CPU. You can see that the, it is consuming many resources. Well, now the the launch that was in charge of running the test trajectory is finished, and well, the movie setup is still running. It is okay because if we wanted to start again a well, a trajectory, um, it must be running. Otherwise, the script will not work. Okay, so now we can press Ctrl C. Let's finish this script and finish this. Close the, let's close the simulation. And let me show you the commands for setting the GPU. I opened the another project, which is the Crazy Fly simulation, and here in its documentation are these commands. And now our GPU is configured. Well, uh, let's um, launch the work again. For some reason, it is not started. Okay, sorry. Okay, I know what was my mistake. We are not working. We are working locally. Definitely, that was my mistake. And yes, I was right. Let's see. Now the simulation is running smooth. Now let's start the robot arm. Let's see if it started correctly. Yes, you can see here the controllers started correctly. Then we can start the move group again. Remember that this is, don't worry about this. And well, now the simulation is pretty fast. Well, and smooth. And if we run the script, look, I think it will be faster than the previous launch. Yes, you can see. You see, the robot closes the gripper, then it moves to an arbitrary position, then the robot um, come back to home. Um, Now it is opening the gripper. You can see that the gripper have this behavior and movement. It is because the controllers of the gripper are not uh, configured perfect, but this can be improved. Look, the script finishes faster than the last time, right? Well, this was the demo. So let's finish the movie to setup, finish the controllers, and let's close the simulation. Well, that was all for this test. I hope you find it very interesting, and also I hope that you have learned something new. For instance, the importance of having a GPU. And let's consider that if, for instance, you don't have a GPU, you can work with Asimovo Cloud, sorry, and there you can decide if you want to use a GPU and depending on the resources you want, right? Yeah, it was shown here the importance of using the GPU, and also you see that how this uh, robot arm performs a movement. So let's see in another time. See you.